Hi, my name is Mitch Van Ochten. I'm a Senior Applications Engineer with ROHM Semiconductor in Novi, Michigan. ROHM offers a very broad lineup of power supply ICs. In addition to the DC to DC converters we present today, we also offer integrated circuits for AC to DC conversion, low dropout linear regulators, USB power management switches, chips for wireless charging, and USB power delivery ICs. Some of the products our power supply ICs have been designed into can be seen at the right. Year by year, we work to increase our maximum input voltage and to offer reduced footprint packages offering similar current ratings as larger packages. This is accomplished with heat spreader pads on the back, use of thermal vias on the PCB, and in some cases eliminating the internal bond wires. We have also developed new technologies such as nanopulse control, which allows for fixed frequency operation with a greater difference between the input and output voltages. The first product to cover is our BD9G500EFJ. It is designed to accept an input voltage range from 7 volts to 76 volts and can deliver as much as 5 amps output current. Its switching frequency can be set anywhere from 100 kHz to 650 kHz. Current mode architecture provides fast transient response and simple phase compensation. Features include overcurrent protection, under-voltage lockout, thermal shutdown, and overvoltage protection of the output. This feature set is common for almost all the DC to DC converters we will discuss today. Rated operating temperature range is minus 40 degrees C to plus 125 degrees C. At ROHM, we understand how difficult a redesign can be when an IC is no longer available. For this reason, we guarantee a minimum 10-year supply of the BD9G500EFJ. If you decide you don't need 5 amps and can get by with a 3 amp part, you can change to the BD9G304FP4-LBZ and save cost. It is pin compatible with the 5 amp part, although the minimum input voltage is slightly higher. Evaluation boards are readily available for both of these devices. Likewise, in many cases, if you have designed in the 3 amp part and find your requirements have changed, you can drop in the 5 amp part with few, if any, changes. In this example, an EV charger project required more 12-volt current than originally planned. By upgrading to the BD9G500EFJ, a board redesign was avoided. Here are some other design wins using these two regulators. The electric bike operates from a 60-volt battery. Typical maximum charging voltage is 71 volts, and the parts have a recommended input voltage of 76 volts and an absolute maximum V-in of 80 volts. The BD9G341A can accept the 60-volt battery input and drop it to 5 volts at 3 amps. The base station remote radio unit is an example of a system requiring operation from a nominal 48-volt supply and having an assortment of loads operating at lower voltages. These parts are designed for fixed frequency operation. The advantage of fixed frequency is that the EMI footprint is essentially the same regardless of load current. This is especially important in systems which are sensitive to noise at certain frequencies, such as the remote radio unit. By knowing the fundamental frequency, you can quickly calculate if the harmonics will land in the region of interest. Other regulators that skip cycles at light load have highly unpredictable EMI radiation, but do offer higher efficiency at light loads. Here's a comparison of the BD9G500EFJ and the BD9G341AEFJ against the competition. For absolute maximum V-in, the ROHM parts win. Now let's move on to another part. Here we have the BD9F500QUZ, which has an input voltage range from 4.5 volts to 36 volts at an output current of up to 5 amps. The part is in a small 3 by 3 millimeter package. It's a synchronous part, which eliminates the need for an external catch diode. It offers a choice of 3 operating frequencies, 600 kHz, 1 MHz, or 2.2 MHz. The lower frequencies provide higher efficiency at the expense of larger physical size for the output inductor and filter capacitors. This part offers you a choice of fixed frequency operation with known EMI behavior or light load mode offering much higher efficiency at light loads. The chart on the left shows efficiency versus load current for the 2 modes of operation. The part includes 2 pins, SEL1 and SEL2, which allow you to select the frequency of operation and to select the maximum output current. It also offers an open drain power good pin. On the right, we have a chart showing the part behavior for various choices of SEL pin combinations. Each pin can be tied low, which is ground, or medium, which is 5 volts, or high, which is V-in, giving 9 choices of behavior. Here we have some preliminary information on the BD9E304FP4 part. This part is also rated for up to 36 volts input and is also a synchronous buck converter. It is rated for up to 3 amps output current and is offered in the small TSOT23 8-lead package. Also shown here are a number of low output voltage DC to DC parts with maximum inputs of 5.5 volts. The BD9B600 MUV can deliver 0.8 volts to 4 volts output at a rated current of up to 6 amps in a 3 by 3 millimeter package. The BD9A201FP4 in the TSOT23-8 package can deliver 0.8 volts to 3.5 volts at currents up to 2 amps. The BD9F500QUZ construction eliminates the bond wires normally used to attach the die to the leads. The die is mounted upside down and its connections are attached directly to the pads on the bottom with high temperature solder, reducing the thermal resistance from the die to case when compared to designs using traditional bond wires. The thermal images shown here illustrate the improved thermal conductivity of the package without bond wires. Finally, a comparison of the ROHM BD9F500QUZ versus some of the competition. The BD9E304FP4 is also wireless construction and eliminates the bond wires normally used to attach the die to the leads. As mentioned previously, the die is mounted upside down and its connections are attached directly to the leads with high temperature solder. The thermal image shown here illustrates the performance of the package without bond wires. Here's a chart showing the efficiency of the BD9E304FP4 with 5 volt output at various load currents and various input voltages. The application circuit at the bottom of the page shows the simplicity of the design. The low internal reference voltage allows operation with output voltage as low as 0.7 volts. The enable pin allows use in multiple output supplies with controlled startup sequences. Here's a comparison of the BD9E304FP4 Synchronous Buck against similar parts from other vendors. Note the high efficiency at 3 amps load all the way down to 1 milliamp load. This page gives a size comparison between existing parts and some of the new parts we have discussed. The improved performance of packaging without bond wires allows the smaller packages to have performance rivaling the larger packages. This chart offers a quick way to locate the appropriate ROHM DC to DC converter part number based on your maximum input voltage and maximum desired current. The part number explanation does not apply for all parts, but is helpful for parts mentioned here. When using a part to feed multiple secondary DC to DC converters, each with their own input capacitor, the total output capacitance may be large enough to force the primary regulator to hit current limit on startup. This can cause a droop in the output voltage and cause a delay in reaching a stable input voltage to the secondary converters. By choosing the appropriate soft start capacitor, this can be avoided. The BD9A201FP4 is a fully featured synchronous buck regulator also in the small TSOT23 8-lead package. It accepts input voltage from 2.7 volts to 5.5 volts and can deliver an output current of up to 2 amperes. It operates at a fixed switching frequency of 1 megahertz, which allows the use of a small 1.5 microhenry inductor. It includes an enable pin as well as a power good output pin. The output voltage can be set anywhere from 0.8 volts to 0.7 times the input voltage. The BD9B305 accepts an input voltage from 2.7 volts to 5.5 volts and can deliver an output from 0.6 volts to 0.8 times V in at an output current of up to 3 amperes. It's packaged on a small 2x2 millimeter package. Typical quiescent current at no load with no switching is 15 microamps. The 1 megahertz switching frequency allows for inductors as small as 1 microhenry in most cases. The part operates at a fixed frequency for higher currents, but switches to light load mode below about 300 milliamps in order to get higher efficiencies. The BD9D300 MUV is a synchronous buck converter with features that make it attractive for battery-operated devices. It accepts a DC input from 4 to 17 volts, which is perfect for 2S or 3S lithium cells. The output voltage can be set anywhere from 0.9 volts to 5.25 volts, and the output can deliver up to 3 amps. It comes in a small 3x3 millimeter package, and the nominal switching frequency is 1.25 megahertz. You have a choice between fixed on-time control with a known EMI footprint or automatic light load mode, which greatly improves efficiency at loads below 300 milliamps. A mode pin allows your choice of operation. It also includes a power good output pin. This concludes our presentation of DC to DC converters for industrial and consumer electronics applications. Many parts have Excel spreadsheets available to help with component selection. Also, upon registration, you can use the ROHM online solution simulator called PartQuest to try your design before building, and encrypted SPICE models are immediately available. LT SPICE models are generally available upon request. Evaluation kits are available for nearly every device we discussed today. Thank you for your attendance.